Okay, I know I'm beating a dead horse even more, but once again, if you look at this problem as a whole, what you're looking at is a fraction minus a fraction. If you don't know how to subtract fractions, you will not be able to do this problem. And it's the same exact concept as what we've been using. When I look at this, oh, there's a whole bunch of stuff on here. That's okay. It's all right. We know how to subtract fractions. What's the first thing we do? We find a common denominator. And the common denominator here is 14. And then we ask ourselves, how did I get from 7 to 14? Well, I multiplied by 2. Okay, let's multiply the top by 2. 2 times 4 times 2x minus 1. How did I get from 2 to 14? Well, I've multiplied by 7. Then I multiply the top by 7. Can you see how I use the same exact concept to work with this more complex piece as I used in the simpler fractions earlier? So practice subtracting and adding fractions so that you can understand this concept as well. Now, looking at this, that's pretty nice because now I'm just going to come over here and use my space more wisely. I can actually make my entire denominator of 14 and write all of this stuff on the top. 2 times 4 is 8. So I can write 8 times 2x minus 1 minus 7 times x minus 3. There, I just wrote it all on top because my denominator is common. If you're not sure why that works, do some fractions that are just numbers and you'll realize that that's what you do as you work with those fractions. Now, this right here on top, oh my gosh, didn't we just do a problem that looked just like that? Yeah, look. This distribution problem, 4 times 2m minus 1 plus 3 times 4m plus 1. That looks awfully familiar, doesn't it? 8 times 2x minus 1 minus 7 times x minus 3. Oh, that's just a distribution problem. It happens to be on the top of a fraction, but I don't need to worry about that. I'm not afraid of that. Let's just forget about that 14 for a minute. In fact, instead of forgetting about it, let's just put that 14 right there on a new fraction. And then let's do this distribution problem and put it right there. You see what I mean by writing everything down and keeping it in order? If you don't, it's really hard to keep stuff in order. What's 8 times 2x? Well, that's just 16x. 8 times a negative 1 is a negative 8. Negative 7 times x is a negative 7x. Negative 7 times a negative 3 is a positive 7 times 3 is 21. Go back and rewind that if you need to. Study it for a minute. Pause it if you need to see how I got from here to here. Now when I look at this, I can combine like terms. Let me give myself a 14. But what's 16x minus 7x? That's easy. That's just 9x. What's a negative 8 plus 21? Oh, that's just 13, isn't it? I think. 21 minus 8. Well, 21 minus 10 is 11. Minus 2 less than that is 13. Okay. Positive 13. 9x plus 13 over 14. I can't combine those two. 14 doesn't go into any of these. None of those have anything in common. I think I'm pretty much in a single fraction in its simplest form. Let's do the next one right here while we're here. It says factor the following completely. Now, factoring right now for you guys is just looking in each of these terms to find out which ones are common. So a lot of you guys did this. You said, well, this is the same as 3 times 5 times a times x minus 2 times 2 times 5 times a times y plus 2 times 5 times a times z. And that's okay. You've taken each term and factored each term completely. However, this itself isn't factored. Okay? Factoring means there's going to be two things we multiply together to get this back. Kind of like if we factor 6, we have 2 and 3. Multiply 2 and 3 and we get 6 back. Well, I don't have two things that I multiply together to get 6 back. But I do recognize one thing. When I spread all these things out like this, I notice that they have an A in every single one of them. And they have a 5 in every single one of them. And because they have that in every single one of them, I can actually pull this 5A out front. I call that undistribution. Remember when you distributed, you multiplied it by everything inside, right? Like on this one, we multiplied by everything inside. Well, we're going to undistribute that 5A, and then in parentheses, we're going to put what's left. I have a 3 and an x left here, 3 times x, minus I have a 4 times y left here, plus, and I have a 2 times z left here. I've undistributed the 5A. So this is a good first step, but then you undistribute and then put in parentheses what's left. Now let's go backwards just to check ourselves. 5A times 3x is 15ax. 5a times a negative 4y is a negative 20ay. 5a times 2z is 10az. Interesting. So that is factored. Two things, 5a and this big mess, multiplied together give me this back. So I have now factored this completely.